the last past please welcome Mr. Fang Yao, sales representative from Pronovo Power Corporation Limited. She will be sharing her expertise about power amplifier and application. Distinguished professors, doctors, ladies and gentlemen, good afternoon. Actually, I'm so happy to be invited as a speaker today to introduce my company Pronovo and Pronovo's here and field simulation amplifier and emulated applications for you. And also, actually, for my company, we are based in Beijing and set up in 1998. Right now, we have two factories. One is in Beijing and one is in Chongqing. And also, we have two technical support centers in China. And meanwhile, there are 15 sales branch offices in China. So for Pronovo, our main market, Chinese market is one of the most important parts for our business. And also we started the international business since 2008. For the international market, we are mainly operate with our distributors in different countries and areas to serve the local customers and to make the good service. Because we don't think the selling is the only thing, but the good support service will be the most important to keep position in the market. So we are happy to be invited as a PTS today. And for in this image, it's briefly showed the main products from the beginning in like. This is the first generation of our protective relay tester. Actually, Pronovo originally produced a protection relay test system in secondary side. And we also provide the primary test system, such as the test system for the current transformer, for the voltage transformer, and right now we also have the digital substation test equipment, especially for IEC 61850 protocols. And I think for today's topic, we are mainly introduce our power amplifier. For power amplifier, we have the different types. The conventional type, the 4-photo power amplifier in switch modes, in linear power amplifier. So for the protection tests, I think for this relay test system will be sometimes it will be used in the health system because in some lab the relay will be configured. So maybe a relay test system will be required to do some testing such as the distance relay, differential relay, overcurrent relay functions. So we have different types of relay tests and supporting, for example, 6 current 4 voltage or 6 current 6 voltage, etc. And this is the digital testing equipment, especially for the sampling value and boost message. Next is about the primary side tested for the current transformer. Actually, this one we also performed the site testing yesterday in PA substations with these units. And actually, for the secondary injection and the primary injection tests for Pronovo in the international market, we are mainly competing with Omicron and Mega. And this is some two-way charging testing facility, which we are mainly supplied in China because the EV car is quite popular in China. I think in China is also the main trend for the car users. So we supply the facility test platform like the mobile UV charging testing and also the handheld UV charging testing to analyze the charging facility. And also some DC, AC over nodes, power loads. And this is another semiconductor platform we developed, mainly used for some semiconductor tests. And for this system, we also already supply to Huawei for some chipsets developments. And this is used also to some special and new material measurement and analysis. I think the last part of the product is about our power amplifier. Actually, power amplifier, we have 2 quadrant amplifier and a 4 quadrant amplifier. In 2 quadrant, it's used the analog signal. So for this one, it's used in the Hill simulator system. And for 4 quadrant amplifier, that means it can be used as both source model and sync model. So for the quadrant amplifier, it will be used in the PHIL system. So when you don't know how to select the power amplifier type, and usually we will check if you will use the Hill or fail system, then we will go the type of the amplifier. Actually, I also learned a lot from today's event, especially for the simulation system, and also learned some case studies. So in my presentation, I will not spend much time to introduce its principle and the scheme. So in this system, this is the conventional amplifier. So it's very simple and also it's very portable. So for this one is the like the current amplifier or voltage amplifier. So and another type is our panel mounted amplifier. For this one, it can be user defined and also it can be configured according to your output channels and output capacity requirements. And for this one, this is another new generation for the conventional amplifier. So this one can be used as individually and also can be panel mounted. For this amplifiers, you can see we have different models. So I think no matter what's your application situation, and once we get your application details, we can make some recommendation and configure according to your system and according to your education purpose. This is the PHIL simulation system. So in this system, our 4 quadrant power amplifier will be used. For this one, it will be used with a simulator together to simulate a virtual system. And the extra part will be they will be used together and give power supply to some other testing equipment, like in the PV, in solar plants, in microgrid. So this is the 4 quadrant amplifiers. And so in this picture, we can see the 4 quadrant. In the first and third, the amplifier is used as a source model, so it will give the power supply to your test objects. And also it will be used as sync model. Sync model means that it will absorb the energy from your PV inverter and stored in case there is some electricity shortage, then it will give it back to your power system. Some diagram for the PHIL. I think for the PHIL simulation, this is the new trend because for the 4 quadrant power amplifier, due to its high power output and its high speed, wide bandwidth, and the high frequency features. So it's a new solution for today's development, especially the electricity development. In 4.0, we also have two types. The two types will be decided on the switch gear, on the power supply mode. For the PAV power amplifier, that is a linear power amplifier. So the accuracy for this kind is quite accuracy and high. But its output power will be not so high as a switch mode amplifier. And this one, when the PAV is doing the sync model, the sync rate could be around 30%. Compared with the PIS, the sync model is a lower rate. For the PAV, we have different models according to the output capacity from 3 PAV 3K to 5K to even to 20K. And in each system, you can use it in single phase, 3-phase, or multi-phase. We also have some customers, they use it in single phase and also in 3-phase to do different simulation experiments. This is the switch mode power amplifier. So for this one, it's the newest generation because for this one, the outputs can be reached as high as 360 kilowatts. And all the sync power can be fed back to the basic power grid. So this is the most benefit for the PS power amplifier. And this one was also successfully used in our customers in Russia to do the to use the PS power amplifier. No matter the conventional or the 2-quadrant or 4-quadrant power, it both supports the analog and digital signal. When the simulator is outputs the digital signal, then we have the DIA01, which supports the Aurora protocol, so it can be converted the digital signal into the conventional signal to the amplifier. So this is the standard models we already had and developed for the PS series, and from 30 kilowatt to 360 kilowatts. And also we have some user-defined configurations sometimes. And so this is some cases we have done together with our overseas customers. For this case, it's a PAV 5,000 is used in the system. So this will is simulate as a power grid and the electronic load, the PV inverter and the power supply and the energy storage system working as a BESS to give power to the system. So you can see here, it can absorb the power from the simulation system, and also it can give the power as a sync model to feed back to the system, to the grid. And this is the physics hardware in the cases. Yeah. And this is another case that which is a little simpler because there is no there is a simple. So you can see the direction is both output and input. Yeah. Also the physics hardware. So this is some experiments we we have done in our factory to in this case we use it as a sync model. This is a PV inverter from Huawei, and the next is about the output power. Actually, in this picture, you can see the power amplifier we get is about 2,300, and here see it's about 2,300. Yeah, so it's very close. And this is also another case we have done in our factory for working as a sync model. This is on resistance load. And also in this picture, it shows that our PAV, this is the PAV 1000 kV. 10 kV, but you can see here is 100% output power. And this is 150% power outputted, and this is 200% power outputted. So the power I remember with 200% output power, it can last about like 60 seconds. Thank you. And the last case, actually, this case is some special because actually in this case, the customer used PAV or system into 3 different directions. For the first direction, actually, they use the power amplifier to collect with electronic dynamic equipment, which next, yeah, and to do with physical generation. Actually, and in these cases, the test object is allocated into different places. For this part, the test devices are is based in the underground, in the same university, and upwards. Backwards, yeah, backwards. And the second direction use is they use to combine with the solar plant, wind plant, to make the energy balance in the university. I will say next. Yeah, next. I think that next. Say this is the second part direction that is used for the campus energy balance used in different sectors. And in the third direction, that it will be used as a source to give the system for their college students to do some development and testing, especially the test equipment developed by their students to do the experiments. So actually for these customers, I remember that when they decide on the system, they are focused on the concentrate that their test objects are allocated in different places. So they need the non-distance communications. So in their case, they are using the fiber optic communications with in their system between different test objects. So that's the main cases I want to share with you. Actually, we have many more cases, and also I know you share us a lot of different cases for the here and the field simulation systems. So I think for Global, we are mainly provide some products, the power amplifier to make your simulation system as a complete system. So thank you for listening and thank you very much.
Thank you much for today ก็เดี๋ยวสำหรับวันนี้นะคะในนามของมหาวิทยาลัยเทคโนโลยีราชมงคลธัญบุรีบริษัท PTS Combination แล้วก็เครือข่ายพันธมิตรทุกท่านขอขอบพระคุณค่ะท่านวิทยากรทุกท่านนะคะสำหรับการแบ่งปันความรู้แล้วก็เทคนิคและก็ประสบการณ์ต่างๆที่ใช้ให้เราในวันนี้นะคะซึ่งเปลี่ยนไปด้วยความรู้แล้วก็แรงบันดาลใจสำหรับหลายๆคนค่ะตลอดทั้งวันเลย แล้วก็ขอขอบคุณผู้เข้าร่วมผู้เข้าอบรมทุกท่านนะคะที่มาร่วมเป็นส่วนหนึ่งของเครือข่ายฮาร์ดแวร์อินเตอร์ลูปในวันนี้ค่ะแล้วก็พรุ่งนี้นะคะเรามีนัดกันในช่วงของเวิร์กช็อปที่ตึกเดิมค่ะชั้น4ห้อง EN 02405ชั้น4นะคะก็คือกดได้ขึ้นไปชั้น4แต่ว่าเดี๋ยวตอนเช้าอะค่ะมาลงทะเบียนที่ชั้น3บริเวณเดิมก่อนนะคะแล้วก็เดี๋ยวขึ้นไปด้านบนจะเป็นห้อง EN 02405เดี๋ยวจะมีน้องๆในทีมพาไปอีกทีหนึ่งนะคะซึ่งเดี๋ยว ขอรบกวนมาก่อน9 โมงนิดนึงค่ะเพราะว่าเดี๋ยวพรุ่งนี้เราจะเริ่มเวิร์กช็อปตั้งแต่9 โมงตรงเลยเพราะว่าคิดว่าน่าจะค่อนข้างเยอะอยู่ใช่ไหมคะอาจารย์บุ๊คแน่นอยู่แน่นอยู่พอสมควรค่ะพรุ่งนี้ก็ยังไงก็ขอให้ทุกท่านมาก่อนเวลาเล็กน้อยนะคะแล้วก็เพื่อเดี๋ยววันนี้นะคะจะมีงานเวลคัมปาร์ตี้ถ้าท่านใดสะดวกก็เรียนเชิญนะคะที่ครัวซุ้มแก้วค่ะซอยด้านหลังห่างจากนี้ประมาณน่าจะสักประมาณ10 โลประมาณ8 ถึง 10 โลค่ะประมาณนี้ครัวซุ้มแก้วโอเคจ้า3 กิโลขออภัยค่ะก็ยังไงสำหรับวันนี้นะคะก็ขอขอบคุณทุกท่านอีกครั้งหนึ่งแล้วก็ขอให้ทุกท่านเดินทางโดยสวัสดิภาพแล้วก็พบกันใหม่วันพรุ่งนี้ค่ะสวัสดีค่ะ